Now, are you ready to learn how we can take limits and use them? First, I've already kind of shown you a basic idea of how to do this, how to find the slope of a curve at a point. Would you like to learn how to do it for real, using limits? Are you sure? The answer is yes, otherwise you get to leave the class because this is where calculus is going now. So, would you like to learn it?
Yeah.
Otherwise you're not going to learn calculus. You're going to learn, well, just basic algebra and limits. That's all we've done so far. Ready to learn calculus? You should be jumpy. Yeah. You can watch that again on YouTube. Maybe you don't want to.
Too scared.
Well, you've never seen a grown man get excited about calculus before? Come on, people.
No.
This is well, first time for everything. 1.5. We're going to talk about tangent lines, we're going to apply them to rates of change, and you're going to see that we can take our idea of limits and turn it into a tangent line, and turn it into a rate of change. It's going to be kind of an interesting idea. I need you to follow through. This is like a, kind of a, not really a proof, it's kind of a semi-proof. We're going to be creating the slope of a curve at a point. I'll give you a definition for how we say the slope of a curve at a point in the next section. For right now, this is what we're doing though. In the first part of calculus, what we want to do is find the tangent to a curve, right? In order to find the tangent of a curve, you need a slope and a point. The point's going to be given. What we want to be able to do is find the slope of a curve at a point. That's our whole idea. So that's why we'll be talking about tangent lines, and then rates of change follows directly from that. So we're going to use limits to find the slope of a tangent line to a curve at a point. I'm going to actually write that down so you understand what we're doing. Again, in calculus, a lot of people get halfway through and they forget what it is they're actually doing. They just get caught up in the formulas and doing the math, and they're not really focusing on what you're doing. What we're doing anytime we do this process, we're finding the slope of a curve at a point, or the slope of a tangent line to a curve at a point. So we're using limits. To find the slope of a tangent line to a curve at a point. Let me say of the tangent line. And that, folks, is the first idea, the first problem in calculus. We're going to create it from scratch. So I want you to understand where this is coming from. Some of you will have seen part of this formula before in your pre-calculus class. Some of you might have seen it in your intermediate algebra class. It's going to look familiar. You're like, wait a second, that's why we did that. Because at the time you're like, what the heck is this? Why are we using it? You're going to see why you're using that. So we're going to invent this formula together. That way you see where it's coming from. Would you like to do that?
Yeah.
Rather than I just give it, I hated that. I want you to see where it's coming from and understand it. Part of math isn't just doing the math, it's understanding it. That way you have a better understanding later on. So here's our creation. Our idea again, I'm going to draw my same curve I did before. We want to find the slope of this curve at some point, and I'm going to call it P again. What was the other point that I used?
Q.
Yeah. Now, our idea was that we're going to take Q and have it really, really close to P, right? That was the idea of a limit, really, really close without touching it. That's the idea here. Now, what we're going to do is define this a little bit differently than I did before. You see, we are going to find the slope of the secant line. That's the line that connects those 2 points. But here's how I'd like to do it. The first thing I want to do is say, okay, P is some point, let's call it x sub 0. Just my point, and it's fixed. It's my actual solid point x sub 0. You okay with this so far? Let's see. Is that straighter or less straight? Is that horrible? Is that better? That's better. It looks better. Am I wearing different size shoes or something? That's horrible. Okay, x sub 0. And this point over, how far is that? How far is that? Well, you can't say, oh, it's 7. Well, there's no actual value, right? We're doing this in general. We don't want to use a different variable. We want it based on this one. But here's how I'm going to do it. I want to say, okay, this is x sub 0 plus a little teeny bit. Are you with me on that? Plus a little teeny bit. Here's why I want to do the plus a little teeny bit. Because I want to introduce the limits to you right now. Because if I do plus a little teeny bit, and I take that little teeny bit and I let it go to 0, think about this for a second. If I let the little teeny bit go to 0, that squeezes point Q all the way over to point P. Do you see it? If I let it approach 0. So here's how we're going to define it. We're not going to call it anything else. We're going to say this is x sub 0 plus a little bit. And h is that little bit. Now keep in mind, this is not to scale, okay? What we actually are doing is P and Q are going to become so close to each other that it's no difference. Okay, are you ready to find out this, the height? Let's figure out those 2 points. How high is point P? Can you tell me that? Yeah, let's assume this function is f. Then that would be f of what now? P. No, not P. Not P. F sub 0, because that's our x-coordinate for P. So far, so good? How about the top point, our Q? Sure, we know to find out the height of our function, we just plug in our x-coordinates. That's how functions work. So we now have this thing. What we want to do, remember our idea is this. Never forget the idea. We want to find the slope of the tangent line to a curve at a point. Our point is point P right now. Are you with me on that? We want to find the slope of this curve at point P, basically, is what we're doing. So this is our point. What we're going to do with that, though, is, well, we need how many points to make a line? How many points to find the slope? You don't have to whisper it. How many? 2. Yes, you're all right. Yeah, you need 2. Yeah, you need 2 points. Say proudly, 2 points. Yeah, you need 2, so we have these 2 points. But our idea is, let's just take point Q and put it a little bit past point P. You follow me on that? Because ultimately, we're going to take this distance and make it 0, or make it approach 0, not equal 0, because then we wouldn't have 2 points anymore. We're going to make it approach 0. That means get really, really close, and that's the idea of a limit. Do you see why we had to have limits before we could do this idea? Okay. Well, let's keep going. Let's find some slope out. Why don't you tell me what is slope? Oh, very good. Okay, rise over run. Give me another way you would do it. Very good. Okay, change in, you have it backwards, but change in, there you go. The change in y over the change in x. Let's find out the change in y and the change in x. Can you tell me, our change in y goes from point P to point Q. How far is that? Or, in other words, how could I figure it out? Okay, let me give you some, okay, hang on. This is 10, this is 3. How far is it between them? Very good. How'd you do it? Subtracted 3 minus 10 or 10 minus 3? Hopefully 10 minus 3. The big one minus the small one, right? So how we do this is we go, okay, well this is not 10 minus 3. It is, do it again for me? Very good. This value, and you could use parentheses if you want, but it's not necessary here. X sub 0 plus h minus x sub 0 will give you the distance between it. This is all of x sub 0 plus h minus x sub 0 will give you the distance between those two x values. Now, if you're still okay with that, it's kind of a big one. Okay, do the math. What's this going to be?
H.
That is h. That's just h. Well, that should make sense. I mean, how far apart is x sub 0 from x sub 0 plus h? It's just h, right? It's just a little bit. If h was 2, it would be 2 apart. If h is 0.00001, well then they're 0.00001 apart. It's just h. Just h. Now, let's go ahead, let's also find the rise. How much is the rise?
F of H.
No, not f of h. Not f of h.
F of X.
If this was 10 and this was 3, the distance between them would be 7. True. Now, how did you do that? Subtractive, so subtractive. You know, I'm going to do this over here so you can see it a little bit better. This is f of x sub 0 plus h, right? This is f of x sub 0. So write that out. Don't do the math in your head, just because you're making a mistake on that right now, some of you. I want you to write out exactly what it is. Write out exactly what I want you to. What is it? F of x sub 0 plus h. That's the first value. What am I subtracting from that?
F of X.
By a show of hands, how many people feel, okay, I'm getting not only the h, but now getting this rise? Feel all right with that? Yes, no? Okay. Now, where did people go wrong and give me f of h? Can you subtract x sub 0 minus x sub 0? The answer is no. You can't do that. That's impossible. You cannot combine those two things. So this is the function at this point. This is the function at this point. Those are two distinct points, right? You can't subtract them and give me the function at the difference between them. That's completely the wrong way to go. Right? This would be the height at x sub 0. That's that one. This is the height of x sub 0 plus h. That's that one. If you find f of h is like way down here, right? H is just a little bitty point. A little bitty, sorry, yeah, f of h. H is right here. That's going to be very different than anything between those. Anything having to do with that. You can't just subtract a function minus a function and subtract the input values like that. You can't do that. Okay, so there's no way we can actually simplify that part of it. Do you agree? Nothing we can do with that. However, can you come up with the formula for slope right now? So we have slope is rise over run, delta y over delta x. What is our delta y in this case?
F of X plus 0 plus H minus F of X sub 0.
Yeah, it's hard to say, isn't it? F of x, that's why you get a master's degree, you can say all this. They teach you all, no, that's not what they teach you. F of x sub 0 plus h, sure, minus f of x plus 0, f of x sub 0. So this right here is our delta y. This right here is our delta x. So right now, we actually have the formula for slope. But I need you to understand where that comes from. Are you okay that this is in fact the rise and this is in fact the run? Are you okay with that? Do you see where it's coming from on your graph? Does that look familiar? Have you ever heard of the difference quotient before? That's the difference quotient. You might have had that in your pre-calculus class. I'm sure you had that in your pre-calculus class. They did a lot of work with that, right? Why? Because we're now going to extrapolate from that and get the slope of a curve at a point. Cool? Now here's the deal. What we've done right now is we have the slope, sure, but is it the slope of a tangent or the slope of a secant? Okay, secant, yes, secant. We have the slope between these two actual fixed points right now, yes? What we want to do is just what we did like the first couple days of this calculus course, not the review, but the calculus part of this. We want to let point Q get really close to point P, and I've said it before in here, but how are we going to do that? We can't change x sub 0, that's fixed, okay? What are we going to do to let this get close to that? What happens? Does h get bigger? Does h get smaller? How much smaller? Infinitely smaller. So infinitely close to In other words, that means let h approach 0. So what we're going to do is we're going to make, so this is a secant right now. In order to get the tangent, we're going to make point Q get close to point P. Make Q get really close to point B, point P. How, you might ask? Well, we're going to take that h, we're going to make it close to 0. That says the distance between them is very, very, very small. Well, tell me something. I can't just say, oh yeah, I'm going to make h 0. I have to introduce something that we've had in this class before. What allows you to take a value, a variable, and move it close to a number? What was that? It's called the limit. So here's how we make the jump from a secant, which is what this is. That's just the slope of, you could do this with any line. It's going to find the slope for any point. That's what it is. If you know the distance points, that's what that is saying. Okay, that is the slope formula. It's just a different way to write it. How we make the jump from this secant to the tangent that I'm going to write over here is we're going to let h approach 0. That involves the limit. That's why we had to have limits. So this one's the secant. We want the slope of the tangent line. The slope of the tangent line is going to look almost identical. It's going to have the f of x sub 0 plus h minus f of x sub 0 all over h. Only now, what do we want the h to do? So we need a limit as h approaches 0. I could have just given you that, right, and said that's the slope of the tangent line. But do you see what's happening here? Do you see how this is the slope of any 2 points that I want? Okay, this is the slope, and this is the distance between those 2 points. And what this says is I'm making that distance get really close to 0. Can it ever equal 0?
No.
No. In fact, if you plug in 0, what happens? You get something undefined. Why does that happen? It says, well, if you only have 1 point, i.e. you let it go to 0 and get there, you only have 1 point, right? Can you find the slope of 1 point? That doesn't make any sense. So you can't let it get to 0. That's why we had to use the limit and say we're approaching 0, where the distance between those numbers doesn't make that much of a significant difference, but there is a small, small difference. That's why we had to have that limit idea. Would you like to see an example about how to actually use this? For sure. I would hope so. It's kind of interesting, right? We just kind of proved that you can find the slope of a curve at a point. Isn't that? That's kind of neat. I know we've done it one time before, but it took a whole lot of work. Now we're going to minimize our work, I hope. So let's try this. We've done this example. We did it the long way. Now we're going to have a nice, easier way to do this. So find the equation. I'm sorry, of the tangent line. To y equals x squared at the point. Right now I'm going to give you an actual point. That's how I've defined our function. X sub 0 is the actual value. It's a fixed point of x. Okay, it says you have an x value of this number. In the future, I'm not going to give you that. We're going to be able to find the slope at any point, and that's even more cool, even more cooler at 1, 1. But the first thing we got to do, we got to figure out what all this stuff is. And where you start is you got to define your function. So in our case, what is f of x? What are we going to treat as f of x? X squared. Good. That's important for you to know that because we're going to be referring back to x squared a lot right now. Also, you need to identify what is x sub 0 for this specific case. In our case, what is the x coordinate, that's our x, of the fixed point?
1.
So x sub 0 in our case is 1. It says you're starting at the point 1. Are you guys all right with that? Not because this is the 1, that would be the output. That would be f of x sub 0, or that's what we do when we plug in 1. But the x sub 0 is 1. That's the x coordinate of our fixed point. You okay with this so far? Now I'm going to encourage you to do a couple things before you just blindly plug this stuff in. I want you to find the f of x sub 0 plus h and the f of x sub 0 independently. So in our case, we want to find f of x sub 0 plus h. Tell me, what was x sub 0 again?
1.
So we want to find x sub 0 plus h, but x sub 0 is 1. I want to find f of what? 1 plus h. Make the jump from x sub 0 to what your value actually is for x sub 0. Do you follow that one? So this is 1 plus h. Give you a head nod if you see where the 1 is coming from. Good, all right. Also, we want f of x sub 0. F of x sub 0 is really f of what?
1.
Very good. So, short little recap. We identify our function. We identify the point. Those two things are there. This right here is your formula to find the slope of a tangent line. That's it. All you've got to be able to do, h is not going to change. You just need to find this thing and this thing accurately, plug it in, and find your limit. This is going to incorporate a lot of things we've done in this class already. So f of x sub 0 plus h, that is f of 1 plus h. F of x sub 0, that is f of 1, because x sub 0 is 1. You with me? Let's start on the easy part. What's f of 1 say to do? Plug in 1. Yeah, plug in 1. Where are we going to plug in 1? Yeah, so plug in 1. How much is that going to give you? 1 squared is 1. Sure. In fact, it should give it to you right here, right? Because that is the output. I mean, it should give it to you. If it gives you the whole point, that's even easier. If it says as at x equals a number, well then yes, you actually have to plug it in on your own. Now, how about f of 1 plus h? What do you do with that?
Turn it into a polynomial.
Turn it into, what do you mean?
Plug
Plug it into f. You know what this meant? This meant plug in 1, right? You know what this means? Plug in 1 plus h. I always told my students, I said, look it, this thing is non-separable. You can't do this. Well, please watch on the board. Common mistake all the time when you first learn this, especially compositions, if you struggle with that. People go, okay, this is f. Okay, I want f of x. I want to do 1 plus h, so they'll give me this. Let's do 1 squared plus h, because that's f of 1 plus h. Do you see the mistake? This isn't 1 f of 1 plus h. That'd be written like this. That's what that would be. That is that. Okay? This isn't f of 1 plus h. It's f of 1 plus h. Okay? You can't separate it. It's like one thing for you. Right? Whatever I have in there, that's what you're plugging in. You don't do f of 1 plus h. You do f of 1 plus h. Like it's one word. Do you get it? You cannot separate it. So in our case, we're not doing 1 plus h. No. We're doing f of 1 plus h. So what's that going to be? 1 plus h squared. Do you see how to get from here to here? Are you sure? Not f of 1 plus, oh please don't do that. It's never going to work for you if you do that. Never. Oh my gosh, that would be horrible. Well, now all we've got to do is take these quantities that you just figured out, substitute them into my formula for my slope of the tangent line, and we'll be done. More or less.
Is that more or less? It's scary.
Yeah, no, it's less. It's stuff you've already done. Very easy. So instead of x sub 0, f of x sub 0 plus h, I've already figured that out. That was 1 plus h squared. That's what I'm going to put first. Minus, instead of f of x sub 0, what did I work that out to? That's why I have you do it off the side, right? You just break it down piece by piece. That's okay. F of 1 plus h was 1 plus h squared. F of 1 is 1. All over how much? Oh, don't forget that h. Don't forget that h. Okay, and now here's where you try to plug in the number. Because this is a limit now, right? This is just a limit, which we've already conquered those sections. You plug in 0. Can you plug in 0? You get, 0 over 0, right? That's a problem, don't you? Or you get something over 0. Looks like 0 over 0 to me. So, we need to do something else then. Why don't we figure out what this is? So let's go ahead and distribute that. Combine some like terms. And see what happens. Don't forget to write the limit. Let's see, that's 1 plus 2h plus h squared minus 1 over h. Did you get the same thing when you distributed as well? What happens here? The ones are gone. Okay, I like that. That's great. So that is the limit as h goes to 0 of 2h plus h squared over h. Oh man, if I plug in 0 right now, it's still going to 0 over 0. What's another thing that I might be able to do? Do you remember whenever we had a 0 over 0, typically what you do is you factor, right? And that sometimes, most of the time, will work your problem out for you. That's what we're doing here. Now, is it a problem for our domain that we'll be crossing out a 0 over 0? Are we actually letting h get to 0? Just approach 0, so that's fine. We can do that. And this is your process for finding the slope of a curve at a point. What you ultimately want to do, you want to cross out this h. That's pretty much your goal. That's it. As soon as you get rid of that, you'll be fine. Plug in the number. So here we have h, 2 plus h over h. Are you okay on the factorization? Can we cross our h's out? Notice how we don't need to get rid of all our h's, right? Just the one that's causing us the problem. Just that one. Notice how I'm still writing the limit. Anytime you have an h, you're going to write the limit. Now, am I okay to evaluate this limit as h goes to 0? Yeah. Now we're fine. We have no issues. Now you stop writing the limit. You write 2 plus 0. 2 plus 0 is, of course, 2. Okay, that's kind of cool. What's the slope of that curve at the point 1, 1? 2. You just found it. You found the slope of that curve at that point. And now it made a whole lot more sense because we got to use limits with it. So the slope of that tangent line is 2. Can you find the equation to the line? What do you need to find the equation for the line? You need two things always to find the equation of a line. Point and slope. Do we have a point? What's the point? Okay. Do we have a slope? We do now, because we just used limits to find one. That's kind of neat. And we've used the slope, now the point slope formula. Y minus y1 mx minus x1. Why don't you plug that in there and see what you get, okay? You can all do that. What you just found on your paper, if you did that by yourself, what you just found on your paper is the slope of a tangent line to the curve x squared at a point. That's the only tangent line that's going to exist at that point. Now here's my question. Is the tangent line going to be different for a different point? For instance, if I give you the point 2, 4, are you going to have a different slope? It's a parabola, right? Yeah, it has a different slope at every single point. Every point has a different slope. So yeah, it's going to be different. You have to redo this every single time. ultimately, I'm going to give you a way so that you can find the equation for the slope of a tangent line. That's going to be a little bit better. So we'll do that at the end. I just wanted to get you this picture in your head because I've actually given you this example before. Do you remember it? I did that example for you. I did it a long way though. It was a ways back. But now we have a better way using limits, and we didn't have to make that jump. We didn't have to make the limit jump because now we define limits, so we can actually use that. Let's go ahead and start one more. I want to get the first couple pieces of this down, and then we'll continue next time. So next up, isn't that neat though? You found the slope of a curve at a point. I think that's just so cool. That's why I love this class. You're able to do some neat stuff. Let's find the equation of the tangent line to this curve. At the point, well, let's see, 3, 1. I want to make sure the idea sticks in your head. So, firstly, what are we doing? What are you trying to find? Slope of the tangent line to this curve at that specific point. So, we are going to be using that formula again. What I want you to do, see if you can find the two pieces that I need first. How about f of x sub 0 plus h? In this case, can you tell me what is x sub 0, please?
3.
Is it the 3 or the 1?
3.
It's a 3. It's the x value. So x sub 0 is 3. So instead of x sub 0 plus h, we're going to be finding f of what plus h?
3 plus h.
So 3 plus h, right? It's one thing. Find f of 3 plus h. So I want that. I know that, oops, sorry. I'll write it up here. X sub 0 equals 3. F of x equals 3 over x. That's always our first step. Find x sub 0 and find your f of x. But now what I'd like you to do in the last few seconds here, find f of 3 plus h, find f of 3. That will take care of your x sub 0 plus h and your f of x sub 0. Did you already find that as I was talking? Firstly, are you okay that x sub 0 is in fact 3?
Yes.
Yes or no? Are you okay that f of x is 3 over x? So we have those two things set in stone. If you want to find, let's do the easy one first. F of 3, that just means plug in 3. You should get that value again if it gives you a point, because that is the output for that number. So we should get 3 over 3, or simply 1. Did you all get 1? Okay, that's the easy one. Now, the other one. F of 3 plus h. Is it going to be 3 over, well, what is it going to be? Are you going to have the h at the end or within the function? Yeah, it's 3 plus h, right? Non-separable. So this is 3 over what? That's exactly right. How many people have exactly that? Good for you. Okay, I'll show you what to do with that next time. We'll actually find the slope of that curve at that point. Alright, so let's continue this problem. We're talking about how to find tangents to curves at certain points, which in and of itself is a very interesting question. Specifically here, we're trying to find the tangent line to this curve at that specific point. And I've walked you through this already. What we're trying to do is fill out the difference quotient, which you guys are familiar with, and then take a limit as h approaches 0. In other words, letting one point get really, 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 really close to this point. Therefore, we have a tangent line to that curve at that point. So we're almost there. We have our f of 3 plus h, we have our f of 3, and we're trying to find out, as h approaches 0, what this thing's going to be. That's what we dealt with last time. You remember inventing that last time, I hope, yes? Okay. So we already have this part. We already have this part. Let's make our substitution, and then let's see what we can do with it. So if we have this, we'll have our limit as h approaches 0. Notice you have to keep writing your limit until your limit is gone. That's a must. Instead of f of 3 plus h, please tell me quickly, what am I going to have instead of f of 3 plus h? Okay. Are you okay on the 3 over 3 plus h? Yes, no, you see where that's coming from? So instead of f of 3 plus h, I have, well, what that equals, 3 over 3 plus h. Then am I going to have a plus or minus? What do you think? Yeah, the formula says minus. Minus how much?
1.
Yeah, f of 3 is 1. All over what, folks? And don't forget that h. So we've just made a little substitution. We have 3 over 3 plus h for f of 3 plus h. Cool. Minus, minus. F of 3, well, that is our 1. So here's our limit as h goes to 0. Raise your hand if you feel all right with that so far. Good, all right. Now, a quick question. Can I cross out the 3's?
No.
You know, I see a lot of people love to do that, right? You go fast, like, oh, the 3's are the same. I get to cross them out. Yay! No, not so much. We can't cross them out because that's a term, right? That's not a factor. We cannot simplify that in any way, shape, or form. So how in the world are we supposed to get this h crossed out? That's our ultimate goal, because right now if we plug in h, we're going to get 0 over 0. Do you see it? That's going to happen all the time if you let h go to 0, because what this is the slope between 2 points. If you let h go to 0, well, you only have 1 point. If you let it equal 0, we're letting it approach 0. So we are going to have 2 points, but we need to find a way to manipulate this so we can cross out our h's so we don't have an issue with this. Any ideas?
Denominator?
What now?
Common denominator?
Common denominator would be great, because right now I have a complex fraction. I have a fraction over, well, a fraction. I need to make it 1 fraction over 1 fraction, that way I can still work with it. So what's our LCD, our common denominator, going to be? Yeah, when you only have 1 denominator, it's that. So instead of 1, notice you're still writing limit. I have 3 over 3 plus h minus, instead of having 1, would you be okay if I put 3 plus h over 3 plus h? Is that the same thing? Sure, yeah, may as well. One becomes that. That is still 1. I'm just writing it special so I have a common denominator. Well, if we continue, well, let's see what happens. We've got a limit still. H is still going to 0. On the numerator, oh, let's check it out. On the main numerator, I know that I have a common denominator of 3 plus h. Notice when you add or subtract fractions, you do not change the denominator. On the numerator, what am I going to have?
H.
Oh, wrong. Say it again. Why?
Minus.
Is that minus important? It's not really important, right? Right? Or yes? No. It's not like we're talking about slope or anything, right? Oh, wait. Huh. That's exactly what we're talking about. So if you have your sign wrong, your line goes from this to this, or this to this. Is that a big difference? Big difference. Freaking huge difference, right? We can't do that. So get your signs right. What's actually happening here is you have a parentheses around that. That's what happens with any rational expression. And this says you have 3 minus h. Minus h. Yes, no? Okay. All over h. That minus is important. So we'll have a limit. It's still a limit. H is going to 0. We have negative h over 3 plus h all over h. Okay. What now? What do you want to do now? Okay. Do we have complex fractions? Sure. We have 1 fraction over 1 fraction. Change that maybe into a fraction. Make it h over 1. You can do that, right? Then what you'll see is I have 1 fraction divided by another fraction. How you divide fractions is you reciprocate the second fraction and multiply. Do you see it? You have 1 fraction divided by 1 fraction. You reciprocate and then multiply. So that'll be negative h over 3 plus h times, I'm going to do this all at one step. I'm going to reciprocate and multiply times 1 over h. Times 1 over h. Are you okay on where the 1 over h is coming from? Are you sure? So I'm reciprocating and multiplying. what happens here?
The H is
Yeah, I don't want to distribute that H, right? Because right now we have parentheses. You were taught in your whatever class you learned this. Extend that line, cross out those H's if you can, because they're now factors. What do I get on the numerator?
-1.
That negative, oh, that's important. -1, so this is the limit. This is the last time we'll write the limit for this problem. -1 over 3 plus H. Would you raise your hand if you can make it down that far? Feel okay with this? Good deal, that's great. Now, wait a minute, H is on the denominator. Can I plug in 0 and be okay?
Yes.
Yes, because I'm adding 3 to it, that's fine. If I evaluate, this is where you stop writing the limit. You say, okay, well what this does, this equals -1 over 3 plus H. Oh, sorry, 3 plus 0. Because now we can let H go to 0. Now that we've eliminated that problem, that's all right. We can now evaluate that limit. We know it's going to be continuous. There's no problems. There's no holes or asymptotes at this point. What's our answer?
-1.
What would you have gotten if you had forgotten to do this negative here? Positive 1/3. Is your tangent line going to be correct? No. No, you would have the inappropriate tangent line. Okay, well, that's all well and good. Are we done now? This is kind of cool, though. What have you found? What is this thing here? Always have that in your mind, what you're doing. You're finding slope. This is the slope. This is the slope of that curve. This is the slope of that curve at that specific point. Do you follow me? Well, that's convenient, and it's not coincidental, but it's convenient because now we have the slope of this curve at that point. We now have a point and the slope, right? What do you need to make the equation of a line? You need a point and slope. So we have that now. I even gave you nice numbers. What a nice guy I am. Look at that. That's pretty cool. Are you okay on where the 1, the 3, and the -1/3 are coming from? We're taking the point that I've given you, we're taking the slope that you have found, and we're now making the equation of the line that goes through that point with that slope. Not sure if you're right with that one. Okay. So we have our -1, that's -1. We have our -1/3, that's your slope. We have our -3, that's the 3. If we distribute, we'll get -1/3 x, and then what? Plus? Plus 1. Very good. We're almost done. If we add 1 to it, y equals -1/3 x plus 2. Very cool idea. This line will intersect that curve at one spot. And it's going to do it at that point. So that is the tangent line to that curve at that point. It's kind of a cool thing. If you want to just talk about the slope of that curve at that point, well, that's the slope of the curve at that point. If you want to graph a line, that's the line. It's kind of neat. How many people feel okay with this so far? Now, the next question is, if I change points, does my slope change? Does my equation change? Yeah, they're all going to be different. Well, that's going to be annoying, because if I ask the next question, okay, find the tangent line to the point, let's see, 9/1/3. Then I ask, how about 2 3/2? Then I ask some more. You'd have to do this over and over and over and over again to find it for any point, right? Maybe we can be a little bit smarter and do it once and for all. Perhaps we could find the equation for the slope and then just plug in the x values. Would you like to see a way to do that? So in other words, maybe I don't want to deal with a specific point. I want to say I want to find the slope of this function at any point. That's what I'm going to show you how to do now. So let's find the slope of the tangent lines . Forgot my L. Find the slope of the tangent lines. That just means the slope of the curve to y equals the square root of x at any point. At any point. Well, let's go through it. You know that ultimately what we want to do is fill out this equation. We know that slope equals the limit as h goes to 0 f of x of 0 plus h minus f of x of 0 all over h. You with me? Now x of 0 stands for a specific point, does it not? If we erase that f of x of 0, we're going to find it for any point x. You can use x of 0 if you want to. I think the book uses that as well, but you don't necessarily have to if we were to be in general, for any general point. So, well, let's see. Can you tell me then, let's figure these things out just like we did before. Can you figure out what f of x is and what f of x plus h is? Let's try to fill this out. Then we'll make a small substitution to there, just like we did right here. And then we should be able to solve this thing out, provided we can eliminate the h. Let's try that together. So everyone, let's look up here at the board. What is our f of x? What's that do for us? So what was it? Square root of x. Very good. Yeah, that's because it says y equals square root of x. That is our function. So f of x is square root of x. So far, so good? Now, how about f of x plus h? F of x plus h. Is it f of x plus h? Like that. Is it f of x plus h, or is it f of x plus h? So what that says to you is x plus h you cannot separate. Right now what I've done is I've separated the x and the h. Do you see that? This is not the square root, this is not f of x plus h. This is f of x plus h. How do I find, let's compare it. So this is wrong. Leave that on your paper, just scratch that out. That is not the correct thing. What is the correct thing? If I want to input all of x plus h into my variable f of x. This is a composition, folks. You got to know how to do compositions. That's why we spent some time on it earlier. It's not square root of x plus h. It's what?
X plus
Not just x plus h. That would be
Square
ignoring
root.
the
Square root of x plus h.
It's the square root, sure. And it says, take this whole thing, put it into the variable. Take the whole thing, put it into the variable. It's square root of x plus h. Notice the slight difference. It doesn't look that different, right? But the square root stops here and it doesn't stop there. This is the square root of x plus h. How many people see the difference there and feel okay with it? Is it important to have that difference? Yeah, it really is. Okay. Are we ready? Can we make the transition? Yeah, we got it. We got everything we need. We have f of x plus h. Got it. We have f of x. Got it. H doesn't change. On your own, why don't you plug that in? Make the substitution. See what you get. I'll do it on the board at the same time. I always like to put this little tail on my square roots to show me where my square root stops. That way I know it's after the h. I would hate for you to keep doing your steps, right? And this happens. First step, second step, third step, fourth. Oh, now all of a sudden it's gone, right? That would suck. Or it'd get longer and longer and longer, and then it's covering the whole thing. Don't do that. Just make sure you know where your square root starts, stops, and what it includes. So f of x plus h, great. Then we have a minus sign, and we have f of x. F of x was square root of x. All over h. Have you got that in your paper? All right, good deal. Now, oh my gosh, how do we solve it? Just give up. Let's just go home. This is pointless anyway, right? Now, if you plug in 0, you're going to get 0 over 0. You see it? 0, 0, that's a problem. So your whole goal here is to get rid of the h here. That's your goal. Now there's of course ways to do it. In fact, I've shown you a problem quite similar to this with involving those square roots. Do you remember?
Multiplied by the conjugate.
Do you remember what the conjugate is? Whenever you have square roots like being subtracted, or square roots in any case, you're taking a limit, one great idea,
Change the sign.
yeah, change the sign, multiply by the conjugate. That's always a good idea to do. Do that right now. Multiply, wait, is it just the numerator or both the numerator and denominator? Both. Multiply by the conjugate right now, okay? You're going to need to distribute the numerator, but do not distribute the denominator. You're trying to get rid of the h on the denominator. If you distribute it, you'll have to refactor it anyway. Hey, does this sign change? I know this one does. Does this sign change as well?
No.
No, okay, good. Remember we have parentheses here, which means you're going to have to distribute. I may have parentheses here, but what I told you is you don't want to distribute where you're trying to get rid of something, right? You're trying to get rid of that h, so don't distribute that, otherwise you'll have to refactor it. So in our case, our limit, keep writing limit, is denominator again. Keep it the same. And you'll see why in just a second. But if you distributed the numerator correctly, hopefully you got this. No more roots. Do you have any roots? Then you probably did it right. Numerator, you're going to get x plus h, because a square root times itself gives you the radicand. That's the inside. So we have our x plus h. That's great. Our middle terms are gone. You're going to get plus root x plus h, minus root x plus h. It's fun to say. And then lastly, you're going to get minus x. Show of hands how we made it that far. Great. What happens? Yeah, we have positive x, negative x. That's kind of what you need to happen, right? Geez, I told you to get it out ahead of time. What's the matter with you? So those are gone. Do you need a tissue? Yeah, I don't have one.
Thanks. Thanks for the offer.
Anybody have a tissue?
It's fine.
Good. I don't think anyone else has one either.
You're so considerate.
Thank you. I care about my students. You're paying my salary. Suckers. No, I'm just kidding. Totally joking. I love you all. Anyway. Please subscribe. 20,000 views.
What happens at 20,000?
Nothing. Just want to get there. Personal goal. What happens now? H's, sure. H's. Do you have anything left on the numerator?
One.
Oh, how sweet. Thank you. Look at that. So we have now a limit. H goes to 0. Can we let the h go to 0 and be okay? If we do, we get x plus 0, which is still x. Square root of x, that's okay. Plus square root of x, that's okay. So we're okay. If we let the h go to 0, what we end up getting is, notice no more limit. You have 1 over square root of x plus 0 plus square root of x. No more limit because I allowed the h to go to 0. When you're all said and done, what's that going to be? I'll give you the 1. 1 over what?
2 squared of x.
Not x, right? A square root of x plus a square root of x doesn't equal x. That's multiplied. But a square root of x plus square root of x gives you
2 square root of x.
What did you just find? What is this? What's this weird thing that we just found?
Equation of any point. Slope.
Oh, this is a what? That's a slope. What you just found is a slope. You found the slope of this. Well, where'd it go? You found the slope of that. That's crazy. Look at that. This thing right here is the slope. It's the slope of this curve, which looks like this thing. That's how that curve looks. It's half of a parabola on its side, right? What you've just done, you've found the slope at any given point, which is constantly changing. That's pretty impressive. So here's my point. Could you find the slope at the point 4, 2? Could you find the slope at the point 16, 4, 9, 3, or anything else for that matter? Could you find the slope of that? Sure, even weird numbers. Find the slope at the point 7. You could do it. It'd be 1 over 2 times the square root of 7. You could find the slope at that. All you've got to do now is plug in the x-coordinate. It will give you the slope of that curve, this curve, at that point. Did you get the idea? So if I say find the equation of the tangent line now for these points, well, you can do it very easily. So never forget that what we're actually doing, we're finding the slopes of curves. This thing is the slope of that curve, this curve, at any point x. So if I had asked you this question, so with a specific point, you'd right now be plugging in which one, the 1 or the 3?
3.
You'd be plugging in the 3. Now, of course, 3, 1 is not on this curve. The point is something like 25, 5 is on that curve. Square root of 25 is 5. So if I said find the slope of the curve at this point, which one would you plug in?
25.
Plug in 25. Do it real quick. What's square root of 25?
5.
Times 2?
10.
1/10. Very easy. You just found the slope of this curve. It's 1/10. That's pretty flat, right? Pretty flat, but still positive. 1/10. Could you find the equation of tangent line? Absolutely. You have 1/10, x1, y1, plug it into that, and now you have yourself the equation of a tangent line. Isn't that kind of neat? Kind of neat. You don't have to do the actual specific point anymore. You can find the equation of the tangent line altogether. Well, at least the slope. Are there any questions before we go move on a little bit? I want to show you a couple applications of this. Yeah.
That's good for the entire domain of
This
that function, right?
this is good for wherever the function is defined.
Okay.
Okay. Yeah. Now, where the function we're going a little bit beyond where we should right now, but where this is not going to work is where the function is not continuous, obviously, because if you have gaps or jumps, there's no slope at that point, right? It just stops. One-sidedly, you can do it. So if it was continuous at the end point, you could do it, but if it jumps from point to point, well, you can't find the tangent line of that. There is no tangent line for that. Also, sharp points are what's called differentiable. That's finding the slope. So a curve that would look like this. See that sharp point? You cannot find the tangent to that point. Why? Well, theoretically, I mean, I could draw an infinite number of tangent lines through that point, right? Because it's not, the slope, it doesn't, I gotta back up to explain this, but what the slope is a limit going to one point, right? The slope is that limit. That means it has to exist and be the same from both directions. The slope going this way is not the same as the slope going this way. Therefore, it would fail. The limit would fail. Therefore, finding the slope would fail. Does that make sense? So, non-continuous points, limit fails. Sharp points, limit fails because the slopes are not the same, and that's what we're looking for. I'll explain this in much more detail later, but if you have an understanding now, well, that's great. Preview. Sneak peek. Ooh, people love those. Sneak peek. Good question. Any other questions? You ready to see some applications? A few applications. Good. How to maybe use this stuff. We're going to talk about average velocity, and then we're going to talk about instantaneous velocity. We're going to see the relationship between this and this come into play again. Average velocity. If I talk about average velocity, that means average velocity. All average velocity is how far you've gone Let me at least write it better for you. How far you've gone over how long it took you to get there. How far you've gone over how long it took you to get there. Well, that's exactly what this thing that I'm about to write up there says. How far you've gone can be, well, f of t sub 0 plus h minus f of t sub 0. That's how far you've gone. Let me explain this to you in English. F gives you your position, true? Right? This is the position when you started. This is the position after a little while. That's the plus h. Did you see that? Position when you started. Position after a little while. That's the plus h. Remember that plus h is a little while? This is your position after a little while. That's how far you've gone. If you have your position when you end minus your position when you started, that gives you your overall displacement, your overall change. If we divide that by the time it took you to change, that's the h. This is the position when you started. This is the position after a little while divided by the little while you were traveling. In other words, displacement over time. That's what that says. That right there, that gives you average velocity. Now here's the correlation between what we've just done. Think about this. What was this? What was this part? This is slope, for sure. This is actually, ignore the limit, okay? This is slope between 2 points. Do you understand? That's slope between 2 points. This is instantaneous slope at 1 point. Do you see the difference? When you get the h0. This right here is average velocity. It's just the slope between 2 points. That's how you find the average value, right? You take the slope between 2 points. That's it. That's what that is. It's the average velocity, just a slope between 2 points. That's how you find an average. So let's do one, and then I'll show you how to translate this into instantaneous velocity. And you're going to see such a connection here. Are you ready for it? So let me walk you through how to find out average velocity between a couple points. So what if I said find average velocity of, here's a position curve according to time. On the interval, let's do 1, 3. Let's do 1, 3. What I want to do right now is simply find average velocity. Average velocity is a slope between 2 points. Now this will give it to you. So what we need to find again is f of t sub 0 plus h and f of t sub 0. But before we do that, we might want to identify what is t sub 0 and what is h. So t sub 0 should be your starting time. T sub 0 is starting time. What's your starting time? No, it's not 0. Your starting time. Where'd you start? You started at 1. Yeah, that's where you started. H is kind of like elapsed time, okay? It's how much time has passed between when you want to start and when you want to end on this position curve. So, can you tell me how much time has passed? How much is my H? Not 3. It would be 3 if we went from 0 to 3. But we're not. We're going from 1 to 3. How much time has passed? 2. Do the subtraction. 3 minus 1 is? H is 2. You okay with this so far? All right. Now that we have our t sub 0 equals 1, our h equals to watch what we can do here. What we want to find out, and you're going to see that this is just the slope formula again. Remember, we created this from the slope formula, right? That's all we did. This is only a slope formula. Average velocity then equals f of, give me t sub 0 plus h. What is t sub 0? Plus, how much is h? Minus f of, what's f of t sub 0? F of what again? All over h. How much is h? I can't afford to lose you right now. I need you to all be with me on this. Do you see where this 1 was coming from? How about this 2? How about this 1, this 2, this 1, and that 2? Huh? Yeah. So t sub 0 plus h, t sub 0 plus h, we got it. F of t sub 0 all over h. You're going to notice that when we're not allowing our h to go to 0, we have a legitimate h, because there's a legitimate distance between these points. Do you see what I'm talking about? This is the difference between average velocity and what we're going to do in a minute, instantaneous velocity. Instantaneous says, what's the time between an instant? Well, it's pretty darn close to 0. Right now, we actually have a legit time, right? We have 2 seconds, or 2, whatever this is, 2 units of time. Can you realize that when you do this, this is f of 3 minus f of 1 all over 2. You with me on that? 2. Don't change your paper, but just watch. 3 minus 1. That's still 2, right? Do you see that this is slope formula? That's all this is. F of 3 says, oh, well, that's y2 minus y1 over x2 minus x1. That's what this is. y2 minus y1 over x2 minus x1. Do you guys see the slope formula in that? That's all that is. Slope formula is just the average between 2 points. If it's talking about velocity, the slope formula, this way, we're doing this way so we can take a limit in just a minute to get instantaneous, but the slope formula just gives you the average velocity. That's it. Do you guys see the slope formula? Kind of neat, right? It looks funky, but that's just y2 minus y1 over x2 minus x1. How do you find f of 3? Yeah, plug that in. Why don't you do that for me right now? Plug in f of 3, tell me what you get. Oh, you know what? Shoot. I got so confused with my f's. What should that letter really be?
S.
Okay, thank you. You know, you can stop me and tell me when I do things like that. It doesn't hurt my feelings. But I hear from your erasures that you all did the same thing, huh? All right. That should really be s, because we're talking about a position curve. We're talking about the s function. So s of 3, s of 1. What is s of 3? Plug in 3, what do you get? Negative 8? Negative 8? Negative 8? Okay. Negative 8 minus, what's s of 1? I don't know. You tell me. Looks like 2. How much is that? Say what?
-5.
-5, that means we're going up or going down. Our displacement's changing on average from negatively. So we're somehow dropping in our position. If I asked you to find average speed, how would you find average speed? Maybe you don't know. Average speed is the absolute value of average velocity. So where velocity has a vector, right, it's vector driven, which means like you have a direction and a magnitude. Speed is not. Speed is just the magnitude. So for instance, if I said the average velocity is -5 feet per, whatever we are, feet per second, the average speed would just be 5 feet per second. Are you with me on that? So this is our average velocity. What it says is, are we always going -5 feet per second? No, but on average we are from one point to the next. That's what this says. If I change this, would this stuff change? Could you still do it? Sure, you understand, it's still, it's just slope. All it is just slope. Okay, I'm not gonna do this one for you. It's the same thing. Now what we're gonna do, let's make the jump about instantaneous velocity. Instantaneous. Well, we already know what average is. We just have it on the board over here. We have that. That's average velocity. The question is, if h is time, not Tim. H is not Tim. H is time. My bad. If h is time, and we want to talk about instantaneous velocity, how much time elapses in an instant?
Very, very small amount.
Ah. That's an interesting question, isn't it? How much time elapses in an instant? Because when you think about it, is it 0?
Very, very close.
If it was 0, that'd be awesome. We could all live forever. Because time would not exist. Right? Because if it was 0, you'd add 0 plus 0 plus 0. Every instant would have a value of 0 to it, right? We would never age. We would just be stuck in the same time. That might be boring for you to be stuck in this class for eternity. It'd be awesome for me. I love this class. Except for you. But yeah, an instant can't possibly be 0, but it can't be anything greater than greater so we can put our finger on it. We can't say it's 0.00001 of a second or whatever you want to say. You can't say it's 0.000000001 seconds, because that would be finite, right? And you could say then, well, between one and the next, you can delineate that. But instants can be smaller than that. Is there time between 0.001 seconds and 0.00001 seconds? Yes, there's time between that. So no matter how small you make that instant, there's something smaller. There's something less small, quicker, even quicker. So from here to here, and then quicker than that, quicker than that. So we can't let it equal 0. An instant isn't 0. But can we let it approach 0? So the idea behind instantaneous velocity is the exact same idea behind the slope of a curve at a point. Because if we have this, which is our slope, and this gave us a slope at a specific point, this gives us average velocity, and if I let my h go to 0, it will give me instantaneous velocity. And that's the same thing. So what you know now is that the slope of a curve is instantaneous velocity. That should make sense. If you have a position curve and you find out how fast it's going up at a certain point, wouldn't that give you velocity? Average would be between 2 points. Instantaneous is at a single point. That's the same idea as the slope between 2 points and the slope at a single point. So instantaneous velocity does the same thing we did with the slope of a curve. It says here's the average. How do we make it instant? I know that this was the average velocity. This was a slope between 2 points. What do I want to have happen to the h if I'm talking about an instant? Where's it going? And what's the only thing that will allow me to let h approach 0? So I'm going to take a limit. That is instantaneous velocity. We just have to understand that, see the connection between it. It's kind of cool, right? It's the same thing. The slope of a curve at a point is instantaneous velocity. The slope is average velocity if you're talking about a position curve. You want to see an example?
Yes.
I thought you would. I hope so, at least. So I have some ready for you. Your position curve is S of t equals 500 minus 16t squared. That approximates some gravity curve probably because the negative 16t squared is about how you approximate that. Dropping from maybe a 500-foot cliff or something. I don't know. Find the instantaneous velocity after 5 seconds. So how fast is this thing falling at exactly 5 seconds? I don't want average. I don't want from 0 to 5. I don't care about that. What if I know this is going to, here's maybe a relationship. What if I know this is going to impact something at 5 seconds? What I'm going to want to know if I want to protect a windshield or something, I don't know, protect some sort of glass, I want to know how fast that's going so I can say, is that glass going to hold up or not? Right? Average isn't going to give it to me. Instantaneous would. So how fast is it going at the moment of impact? How fast is that going? Then you can derive how much force that is and how much you're going to have to hold up under a certain load or whatever that case may be from physics. But here, right here, this is pretty important for us to be able to find the instant velocity of an object at any given time that I say. The given time I say is 5. Now you can see a connection between what we just did and what we're going to do now because it is the same exact idea. What we want to know is instantaneous velocity. And what I've given you is that's the limit as h approaches 0, s in this case, t sub 0 plus h minus s of t sub 0 all over h. What is your t sub 0? What's the time at which you want to find the velocity?
5.
So you know that t sub 0 is 5 seconds. Okay? There is no starting and ending time, folks. You're starting at 5 and you're stopping at 5. Well, you're stopping just a little teeny bit past 5, but it's so close you can't tell the difference. So there is no 2 times. There's no average. There is only one. There can be only one Highlander. So it's just like that. Anyway, so t sub 0 is 5. Can you do what we did before? Can you find s of 5, s of 5 plus h? Do you see where the s of 5 and s of 5 plus h are coming from? That's what we want up here. We actually just did those examples just a little while ago. Now, another question is this. Could I have asked it a different way? Could I have asked it, hey, find me the instantaneous velocity at any time? I hope you're with me on this. If I asked it, find the instantaneous velocity at any time, would you have a 5 here?
No.
Would you have a 5 there? You would just leave it as t, and then you'd come up with a formula, and you could plug in any time that you want. How many people feel okay with that idea? So that was the 2 connections that we had to make. So let's go ahead, let's plug this in. What is s of 5 plus h? Can you tell me? S of 5 plus h. That says go to the s position curve and plug in 5 plus h. Don't all talk at once. 500, great. Okay, 500. And Sarah, you said minus. Minus what?
16. 5 plus h.
16.
5 plus h.
5 plus h. 5 plus h is non-separable. It has to be there. 5 plus h. And then what? Well, let's look at it. Are you okay getting from here to here? You see where it's coming from? This is just the position curve at 5 plus h. It's a composition. Take this, put it there. How much is s of 5? S of 5 says take 5, plug it into your function. What do you get?
500 minus 16.
500 minus...
16 times 5 squared.
Sure, so 500 minus 16 times 25. I have no idea what that is. Help me out with that. Y'all have calculators? Go quick. How much?
I think it's
100?
100.
I'll believe you. Okay, I kind of had some drop-off in participation. Ladies and gentlemen, do you know how to find the 100? Is it 100? Do you know how to find the 100? Do you know how to find the 500 minus 16, 5 plus h squared? You see where that's coming from? You sure? We're taking this, we're substituting it into our function. That's 5 plus h, that's our t sub 0 plus h. That's giving us this expression. If we're to substitute these two things, well, then we've got h. We have 500 minus 16, 5 plus h squared minus 100.
That's 550.
Better? We'll continue this next time. We'll find out exactly how much instantaneous velocity is. Get that out. Well, anyway, good afternoon. How are you guys doing? Good. All right. We're going to continue talking about this problem. Now, what we're doing is we're trying to find not the average velocity of something, which is, we found out last time, simply the slope between 2 points. We don't want to find the average, displacement over time. We want to now find the instantaneous velocity. So, how fast is an object moving at a specific point in time, an instant, like at that one moment? It could change before, it could change after, but right then, not an average, but an instant. Like, I think I gave this example. If you're driving down to LA, if you go from here to LA, let's say it's about 300 miles, right? If you make it in 5 hours, how fast were you going? See, a lot of you are saying 60 right now, right? Because you're doing 300 miles divided by 5 hours would give you 60 miles per hour, true? That would be your computation in your head. However, what you just did was an average velocity, an average speed, as a matter of fact. Velocity, if you want to consider the direction. But that's an average, right? The overall distance divided by the overall time gives you how fast you're going on average. Now, realistically, are you going to be driving exactly 60 miles an hour from Merced to LA? No, not if you've ever been to LA. Because when you get to LA, you're going like 20 miles an hour. When you're in Fred, you're like 80. Boom, and you're going, right? You're not always going 60, you're going faster, slower, you hit the brakes, a semi-truck pulls in front of you, you flip them off, you go faster, you know? That's just the way it works. So we're not talking about the average velocity here. We want to know, what was your exact speed the moment you crossed the Bakersfield city limit? That's the question we're asking now. What was your exact speed the moment you left Merced? You looked at, okay, I was going 63. Maybe I hit Bakersfield, I'm doing 90, you know? It doesn't have to be 60 all the time. It could be an instant speed. That's what the idea is. What we found out is that in order to find the instantaneous velocity, we came up with a formula that was actually the slope of a curve at a point. That's the same exact thing. The slope of a curve at a point is the velocity of a certain point of that curve. So for us it was... Did it involve a limit or not? Do you remember?
Yeah.
The reason why it involves a limit is because the h that we're about to put on the board represents your time. And in an instant of time, how much time passes? Well, very little. And that's what we say h is going to 0. Because very little time is passing. A little is passing, but it's not quantifiable. And that's what h approaches 0 actually says. So we go, okay, well we know it's a limit as our time, our h. The distance between t sub 0 and t sub 1, the difference in that is going to 0. Position after you end minus the position when you start gives you your displacement over h, which is your distance, or sorry, your difference in the times. How much time has elapsed? We're letting h go to 0 because we're now taking an instant of time. What we need to be good at is taking this information, plugging it into this limit, and then using what we know about limits to solve the problem. Let's see if we can do this together. Are you ready for it? So there's two options that you have when computing these instantaneous velocities. Option number one is, well, you could compute it for that specific point, right? In this case, what is your t sub 0? Could you tell me your t sub 0 here?
5.
Sure, 5 seconds. T sub 0 because that's your starting time, and you know what? That's also your ending time. We want to know what happens at exactly 5 seconds. So t sub 0 would be 5. The other option that you have is do it in general for any time and then plug in 5 at the end. Do you remember us doing that last time? We found out the entire instantaneous velocity for any time, and then we just plugged in a number and found out it was the same as what we thought. So we just plug in those numbers later. Which one would you prefer? Because I don't care. Do you want to do it with the 5 or do it in general and then plug the 5 in?
General.
With the 5? Do it with the 5, whatever. So what we want to find out is S of t sub 0 plus h. We need to know that. And we need S of t sub 0. Now, in our case, how much is t sub 0, please?
5.
So this now is 5. And this is 5. 5. 5. We want to find out those things. Now, since we have a specific time, it's not t sub 0 anymore, it's, well, 5. 5 plus h, and s of 5. Are you guys okay with that so far? Let's see if we can figure this out. Try it on your own if you'd like. I need you to find s of 5 and s of 5 plus h. What does s of 5 mean for you to do? Plug it into where? Where? Sure, yeah, this says plug in 5 right there. Why don't you plug in 5 there and see how much that gives you? Has anybody done that already? How about s of 5 plus h? Remember I say it like 5 plus h because it's non-separable. We don't want s of 5 and then plus h. That would be the wrong way to go. We want s of 5 plus h. Like one thing, it's got to be in parentheses. 5 plus h must show up again in parentheses in your problem. Tell me what s of 5 plus h is going to be, please.
500.
Okay, I like the 500. Then what?
Minus
Uh-huh.
15.
16, great, that's got to be there. Then what, please?
500.
Good, very good. That's just a straight up composition right there. You're taking 5 plus h, you're plugging it in for t. That's all you've done. Raise your hand if you feel okay with this so far. Good deal. Now we're ready to make a substitution. We can take these quantities, plug them into those expressions, and get our limit. So we're going to have a limit. Instead of s of 5 plus h, I'm going to put this expression that s of 5 plus h is equal to. That's 500 minus 16, 5 plus h squared. This is s of 5 plus h. Do you agree? You sure? What's next? Minus what?
100.
Where are you getting the 100? Yeah, that's s of 5. So we have that. All over how much? H. Now it's going to involve some algebra, but I need you to break that up. I need you to distribute that. Can you just do 25 plus h squared? Square this one, square that one. Does that work? Please shake your head. Please show no. No, you're going to have to distribute. So distribute that. Notice we're still writing the limit. Still a limit. It's still going to be over h. You're going to have quite a long expression here. Here's what's going to happen. I'll do this in 2 steps. Firstly, the 500 stays the same. Next step, I'm going to put the minus 16, and then please watch what happens. Don't do this all in your head. Don't do this all at one time, because you're going to make a sign error on the last 2 terms of this polynomial if you try to do some of this in your head. Here's what I mean. You're going to have this minus 16. This means multiply, right? This you're going to do, and you're going to get 25 plus 10h plus h squared. Did you get that as well? You sure? However, notice that this is in parentheses. Do you see that? So what are you going to distribute? 16 or negative 16? That negative is going to change all those signs. These second signs are going to change as well. So that's important. Don't forget the minus 100 either. So after that, help me out. Let's do this multiplication. This is the limit. H goes to 0. 500. Tell me the next few. What is that? 400?
400.
Minus 160h? Minus 16h squared? And then lastly, we'll have this minus 100. Don't forget about that. Hey, take a look at the board. This is going to be kind of nice. Do you see anything special that happens here? What happens up here? What happens? What happens to all the constants? They're gone. You have 500 minus 400 minus 100. Do you see that? All the constants are gone. What you're left with is the limit. Still going to write the limit. H goes to 0 of negative 160h minus 16h squared over h. We're on a roll. Tell me the next thing we're going to do. Factor what? Your whole idea here, you can factor out 16h as a matter of fact if you want to. Your whole idea here is to cross out h's, right? That's it. That's all you want to do. So if I factor out, I'm just going to choose the h, and I'll show you why in a second, why I'm not going to do 16 or negative 16h. I'll show you why. If I factor out the h, I get negative 160, no h, minus 16h over h. Do you agree? What happens to the h's? They're gone. Okay, I love it. Now that they're gone, are you able to evaluate h going to 0? Well, if you do that, look what happens. Then this limit is negative 160 minus 16 times h. How much is that? It's minus 0, right? So negative 160. Why I didn't factor out the 16? Because it's not really necessary. If you did, you'd have to multiply it by 10, and then you'd still get negative 160. You with me on that? So on this, in our problem, we have negative. What's negative 160? What's that even mean? What's negative 160? What did we just find? You got to know. You got to know what we just found. Okay, you're both right. I heard some people say instantaneous velocity. I heard some people say slope. You're both right. What you've done is you found the slope of this curve at a specific time. What time was that? In other words, you found out how fast this particle is. Was it falling or climbing? How fast this particle is falling after exactly 5 seconds. So when you took a stopwatch and you went 5, and you timed it and you said how fast is it going? Negative 160, whatever it is, meters per second, feet per second, whatever this is based on. That's what you're finding. This is the instantaneous velocity in units per second. So let's assume it's feet. Feet per second, or meters per second, miles per second, however what our units are. Does this make sense to you? Could you do the same thing in general? So for instance, if I said, now do it for the time of 7 seconds. Well, you wouldn't want to redo the whole thing, right? So in that case, if I ask you for several times, it might be best not to use the 5 at all right now. Might be best to leave it in terms of t. If you did, would you like to see that it comes out the same? You want to see that?
Yeah.
Let's say we leave it in terms of t. What this is going to do is give you a formula for the slope, a formula for the instantaneous velocity, and then you plug the time in later. That's kind of nice. Notice what's changed? We don't have an actual number to plug in, right? S of t, we just write down S of t. You okay with that? Yes, no? S of t plus h, well sure, we have t plus h over here. If we do this, if you substitute in these expressions for these, the function notation up here, we have 500 minus 16 t plus h squared. That's this. Minus, I need to put parentheses around this because I'm subtracting this entire expression. 500 minus 16 t squared. Got to do that. All over h. From here on out, man, the calculus is almost done. I mean, all you got to do is do some algebra. Do you see, firstly, why we have to have those parentheses? Subtracting that entire expression, this negative is going to change to a plus. That's going to really affect your problem. If you didn't do that, some things are not going to work out right for you. Here we'll have 500 minus 16, and then in here we'll get t squared plus 2th plus h squared. Just foiling. T squared, 2th, h squared. Minus 500 plus 16t squared. If we distribute that negative 16, negative 16t squared minus 32th. Oops. Minus 16h squared minus 500 plus 16t squared. All over h. Hey, I'm doing this fast. If I've made a mistake, you need to let me know. Have you guys been able to follow that? Am I right on that? We're all right so far? So we distributed, got all this stuff together. What's the next thing you're going to do? What do you think? Probably combine anything you can, right? Combine anything you can. So let's look at what happens. What can you combine? What happens up here on my problem? 500s. They're even easier to see here, right? 500, negative 500. What else? Look what would have happened if you forgot to distribute the negative. You'd have negative 32t squared, wouldn't you? The h wouldn't factor out. You wouldn't be able to simplify it. You would be stuck. But here, since we got our signs correct, those are gone. Can you combine those ones? But we can, yeah, we can factor the h out. I'll give you two steps here. We got negative 32th, sorry, minus 16h squared all over h. Yeah, of course we can factor the h. So, okay, we'll do that. We'll factor out the h. Remember, I don't care about factoring the numbers right now. You're gonna be plugging them in anyway, or you're plugging a number to this anyway. So you don't care about that. The h's are going to 0. Ultimately, you get the same exact thing. We just care in this case to simplify out that h. Show of hands, how many people are with me so far feel okay on this? Good deal. Have you seen that after you know the limits, it's really just about your algebra? They say that people take calculus to finally fail algebra. I don't want that to happen to you. I want you to know you know your algebra. The calculus is actually quite easy. It's not going to be hard. The fundamentals, you'll all have those down. I guarantee you'll have them down because I'm teaching them to you. But it's algebra. Be very cautious on your algebra, your signs. Just simple stuff. H's are gone. Can you let h go to 0 now? Yeah. Do you also let t go to 0?
No.
We're just talking about h. So this is what? Wait a second, though. Why does this have a t in it? Oh, because this is now a general formula for the slope. It's now a general formula for the instantaneous velocity. Now if I say, hey, find me the velocity at 8 seconds, could you do it? How about 5 seconds? How about 0 seconds? Could you find it at any point that I ask you? And this is a little bit more powerful than the thing we just did. So now at 5 seconds, geez, I hope it works out right. If it doesn't look like an idiot. At 5 seconds, the velocity would be negative 32 times 5. Is that what we had before?
Yeah, negative. Stressful
job I have here. Negative 160, again, feet per second. Same exact thing, same sign even. By the way, how would you get speed from this? This is a velocity. How do you get speed? So what's the speed here? 160 feet per second. So speed doesn't have a direction, velocity does. So if you get a question that says, what's the instantaneous speed? Well, you just take your absolute value of your instantaneous velocity and you'll get the speed. It's just the magnitude of that vector, not the direction.
So how can velocity be measured negative and positive?
Up, positive.
Up and down. Okay.
Down, negative. Climbing, falling.
Okay.
Rockets have a positive velocity when they're climbing and a negative velocity when they're falling. This was a man thrown off a cliff, 500-foot cliff. He had negative velocity. That's what happened. True story. Okay. Last thing in our little section here, there's another connection I need to make for you. You already know that this calculus stuff is pretty intriguing because we've just found out that the slope of a curve at a point is the same thing as instantaneous velocity, right? So we find out the same way, which is kind of cool. The other thing we're going to find out is something about rates of change. Rate of change. You know, we normally say that what is our rate of change? For instance, if I give you a straight line like this, what is the rate of change? What do we call that? Slope. No, not it is a straight line already, right? So the straight line can't have a tangent to it. Well, it can't have a tangent to it. I'm not going to consider that to be a tangent. The straight line is itself has a, in and of itself has a rate of change, and we call that rate of change slope. We say we're going up 2 and over 1, right? Or going up 1 and over 5, going down and all that stuff. That's a rate of change. So slope is a rate of change. Just a basic example here. What's the rate of change? Why would you say 3 over 1? He's right. Why would you say 3 over 1? That's a slope. Slope is a rate of change. So the rate of change is 3 over 1. How about for this one? What's the rate of change there? Sure, -1 over 1 if you want to say 1, or just -1 would be the rate of change. All right, here's what this says to us. Here's the jump we can make. Well, if slope is a rate of change, and we know that, well, if you look at this, velocity is a rate, right? The rate of change here instantaneously was, well, the slope of a curve at a point. And that's what we're saying here. If we want to find an instant rate of change for a curve, that's just the slope of the curve. A rate of change is a slope, right? If we want to find the slope of a curve, that's instantaneous rate of change. And that's what we're saying. So, since a rate of change is a slope, an instantaneous rate of change is the slope of a curve at a point. Of course, we need to make it a little bit more mathy than that. Here's the mathy part of it. This is going to go very quick because you can see it's exactly the same thing that we've just been doing, okay? Here's a rate of change. This would be considered your average rate of change. Average rate of change is exactly like this. It will be that. Why that?
Isn't that also our secant?
Secant. In other words, it is the what between 2 points,
Distance.
not the distance. Distance formula have a square root.
Average.
It's the average, that's why it says average, sure, but what does this formula give you? Oh, come on, we spent so much time doing that. What's that formula? Difference quotient gives you what? The, not the tangent, but the slope of the tangent, yes. So what is this? This is just slope, right? That's just slope between 2 points. That's what we're saying. The rate of change is a slope. The rate of change is a slope. That's an average rate of change. How I find the instantaneous rate of change is do what to this thing?
Add a limit.
Put a limit on front. As h approaches what? Yeah, so that's how we're going from an average rate of change to an instantaneous. Are you starting to see that every one of these things is almost identical? Average is just a slope, okay? Instantaneous is the limit of that slope. It's saying find it at a point. That's all we're doing. So if this is the average rate of change, the instantaneous rate of change is identical to an instantaneous velocity. It's identical to the slope of a curve at a point. It is a limit, as h approaches 0, of the slope. It says, what's the slope as you approach 1 point? That's it.
Now, is it acceptable to solve, say we want instantaneous velocity, to first work out our slope of our secant, and then just once we have that all worked out, then just add the limit to it and solve that way?
Definitely not. Because your slope of a secant is going to be an actual numerical value, right? Like 5. When you take the limit of 5, it's always 5. So what you're saying is, what you'd be implying there is this question.
Or maybe I'm saying it the wrong way.
Here's the question you're implying. Is the slope between those 2 points, which is your average slope, your average rate of change, understand? Is this slope the same as this slope? Possibly. What about this slope? No. What about this slope, that slope, that slope, that slope? No, 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 no. So no, you can't just do the average rate of change and say, oh, this is also an instantaneous rate of change if we take a limit. You can't do that. What you can do is say, I'm going to consider my slope function and then make the h go to 0. And that's a different way of saying it.
Okay, that's what I was trying to, like, on the test, we could figure out, solve for, get rid of the h on the bottom, and then add in our limit once we've had it all simplified down, and then solve the limit.
Yeah, that's exactly what you're doing here.
Okay.
That's it. Okay. Well, I'm not going to do this problem for you, but I would like to set up, just talk about it a little bit. Let's say that I have a problem to find the average and the instantaneous rates of change of a curve. The average, I'd like that over 2 comma 5. And the instantaneous at a point of -2. Can you explain to me maybe a little critical thinking here? Why am I giving you a range of numbers for the average, but I'm only giving you, I'm actually giving endpoints for the average, but I'm only giving you one number for the instantaneous? Why is that? Oh, well, it's not technically at 1 point, but it's over such a small distance that we consider it to be 1 point, right? So what we want to know here is average is over, yeah, it's over distance of time, right? It's over distance and a time. We're saying compare the distance to this overall elapsed time. How much time elapses in an instant? Pretty close to 0. That's why I give you only 1 point here. So could you do both of these things with this information? We're just going to talk about it. I'm not going to do it for you because I've already given like 5 examples of the same thing. Here's how you do the average. In our case, our average, our starting spot would be, what's our x sub 0 for this case? That's where you start. How much is your h?
3.
Why is it 3?
Minus 2.
Good. So in our case right here, x sub 0 would be 2. H would be 3 because that's the distance, that's the elapsed time that it took. That would be 2, that would be 3. Are you okay on the average rate of change for that one? You'd plug in the 2 because that's where you started. You'd plug in the 3 because that's how long it took you. You'd calculate that and you'd plug it into your function. We've done all this stuff before. You take your 5, you take your 2, and divide by 3. You plug in your 5 to your function. Plug in your 2 to your function, then you figure that out and divide by 3. Can you follow that? You sure? All right. Do I need to do it for you, or are you okay? Okay. That was not an answer. Silence. Yes, no?
No.
You all right? You want to see it? Good. Because I don't want to do it anyway. Forget you guys. Whatever. Plug in 5, plug in the 2. What do you get when you plug in 5? 71? What do you get when you plug in 2? 8? Over 3? 71 minus 8.
63.
That would be your average rate of change for that one. That's how you figure it out. Plug in the 5, plug in the 2 to your function. I plugged in right here. Then divide by your h. That's average. I'm definitely not going to show you the instantaneous right now because we've just done that. For instantaneous, again, you have 2 options. Your x sub 0 would be -2. So you could find negative 2 plus h, f of negative 2, then do your limit, right? Or you could just do this with your function and then plug the number in later. We just did that example right here. We did that twice. I showed you how to plug in the number, and I showed you how to not plug in the number and do it later. That's the same exact problem right there. How many people feel okay with this one? Good deal. Now, we're going to